Hey guys, we have now learned how to change things into scientific notation, what scientific notation is, and now we even have started some operations in scientific notation, including multiplication and division. Uh, what are the other operations? Well, of course, adding and subtracting. And that leads us to page 22 in your math binder. So make sure you have page 22 and 23 handy. We're going to go through both of these. We're going to learn about adding and subtracting in scientific notation. So get your pens, pencils ready, get your brains ready, and let's get going. I don't know if you guys are aware of this, but so much of understanding complex mathematics really boils down to understanding the difference between addition and multiplication. If you understand that those two things work in a different mathematical fashion, then you can apply a lot of that to anything with variables, anything in different forms. So before we get into adding and subtracting in scientific notation, we need to do a quick review and just help our brains remember how adding is different from multiplication just in general. Okay, so what you guys are going to do for me right now is this box right here. It says review. Use your knowledge of simplifying expressions, which you did a lot of in 6th and 7th grade. Use your knowledge of simplifying expressions to complete the following problems. Okay, so you're going to pause the video right now, and you are going to try, maybe use a pencil just in case you mess them up, or if you use a pen, that's okay. When you come back and look, you can just fix them, cross them out and fix them. Now, in these moments when I say pause the video and try it, it really is so helpful and good for your brain and good for your learning to actually do that. It does more for your brain if you pause it and try it first than if you just wait and let me go over it. So everybody right now, pause me and try 1 through 8. Ta-da! See how you did. A couple of key things here that maybe don't seem like that big of a deal as you're working at it, but actually the difference between 1 and 2. Honestly, understanding so many things in mathematics really boils down to, do you understand that x plus x is 2x versus x times x is x squared? It seems like a very basic thing, but it's a very important mathematical skill. Understanding how when you add, if I take an x and I add it to another x, I still have x's when I'm done, I just have more of them. Versus when I multiply, I completely change the size of this. X times x is no longer x's, it's now x squareds. Likewise here, if I have x squared plus x squared, those exponents are not going to change because I'm adding. If I have x squared plus x squared, I now simply have 2 of them, 2x squared. Notice with addition, you do not change the unit size, okay? They are still x squareds, I just have more of them. However, with multiplication, you do change the size. Addition, still x's. Multiplication, I've really changed the size. That means with something like number 7, if I'm trying to do x squared plus x cubed, I can't really do anything with that until I know what x is. I can't add those together because they're not the same size. But I can multiply them because multiplication is going to change the size of it anyway. So one key thing that's really important here is with addition, you can only add things together that are the same size. And that's always been true. When you're adding things, they have to be the same size. That's true with fractions and decimals and everything else. If I'm adding 1/4 plus 1/2, well, I can't do it until I get them all 2/4 the same size. If I'm adding centimeters to inches, I can't do it until I get them all to either centimeters or inches. I have to make them the same size. However, with multiplication, you can multiply anything because you're going to change the size anyway. I'll say that one more time. When you add things, they have to be the same size. When you multiply things, they don't because you're going to change the size anyway. Let's see how that applies to what we have been doing. All right, check this out. The table shows the population of the 3 largest countries in North America in 2011. So this has probably changed now because we're almost a decade later. But the United States in 2011 had a population of 3.1 times 10 to the 8th. Hey, that looks familiar. That's scientific notation. Why? Because it's a really large number. Canada had a population of 3.38 times 10 to the 7th, and Mexico, the country of Mexico, had 1.1 times 10 to the 8th. Okay, so standard form, it says right here, find the total population of these countries in 2 ways. Standard form means change them into regular numbers with all the zeros and set up your addition problem and solve it there. Scientific notation means, can you try to add them together in the form that they're given? So once again, you are going to pause me and try this in 2 ways. Total population means addition, right? Addition. So you're going to add them together in standard form, the normal way you would have in elementary. Think back to that. What do we need to do to add these together? And then see if you can add them together using scientific notation. Pause me and give it a try. Okay, check it out. Standard form. Now, one of the things that's really important with addition, and this is going to connect to what I was just telling you about addition and how things have to be the same size. One of the things that's always really important about addition is lining up those place values. It's all about place values, right? So I put the commas in and I messed up right there and put a comma, and then I was like, wait, that's weird, a comma doesn't go there, and then I scribbled it out. So I took all of these that were in scientific notation and used those skills that we learned last week and switching back and forth and went, okay, that one needs to move 1, 2, 3, 4, 5, 6, 7, 8. So I moved past the 1 and then put 7 zeros on it. So I took all of these scientific notation, put them back into standard form. This is why actually we put commas in really large numbers, is it helps us balance out the place values and remember where we're at. So I made sure to line up my place values, because with addition, you have to line up the place values. That's one way of making it the same size, is we shift those place values and we say, okay, I'm adding these, you know, millions to other millions, and I have to make sure the sizes are the same. Place value. We do it with decimals too. When you're adding decimals, you line up the decimal so that you're getting the place value right. If you typed it in calculator, one very common mistake that people make is it's easy to lose track of the zeros. Maybe you put in 1 too many or 1 less, and now you have messed up your place values, which is really going to mess up your answer. But you should have gotten to this just in standard addition. 453,800,000 is how we read that out in standard form. Now, scientific notation. Some of you maybe got a little stumped on that one, just came back to the video to see how it works. That makes sense because that's the new part. Some of you might have tried adding it all together. Some of you might have went, hey, okay, well maybe like we did before with multiplication and division, we said multiply the coefficients and add the exponents. Maybe I can just add up the coefficients. And I'm going to tell you that you can, but not quite like this. If you take a look at this green statement that I have here, what would be wrong with just adding up these decimals? Let's see. Okay, if I do 3.1 plus 3.38 plus 1.1, if I just try to add up the decimals, 7.58, well, I already know the answer, and this just isn't working out. This is not going to get me to the right place. How come I can't just add up those decimals right now? Oh, because with addition, things have to be the same size. Are you ready for me to show you something super tricky right now? Right now, when I say things have to be the same size, remember we talked about yesterday too, this power of 10 is the place value. It represents the place value. What does it represent? The place value. And if I want to line up place values, which I need to do with addition, then I need to make sure that these place values are the same. So I didn't have to worry about this with multiplication because I was changing the place value anyway. So my powers of 10 went all over the place. That's fine. Multiplication changes the place value. Addition is not supposed to. So these two place values are already the same. This place value is off by 1, which is why adding up those decimals was not working. It's not going to work until I fix this place value. What do I need this place value to be? I need it to be bigger by 1 so that it matches these other ones. If I want, remember our balancing act the last few days? If I want this place value to go up 1, I need this decimal to go smaller one. Watch this. You ready for this tricky thing? I'm going to try and write this all in one big row. No, it's not going to fit. I'm not going to try that. It's 3.1 times 10 to the 8th. I'm not changing that one. It already had the right place value. I am going to move this one, and I'm going to change it to 0.338 times 10 to the 8th. Isn't that so tricky? And I know you're thinking, Miss McGowan, you just changed that out of scientific notation. And you are correct. I did that. And I did that for a very important reason, because now my place values match. So keep going with me. I'm going to leave this one alone, 1.1 times 10 to the 8th. As soon as you get all of the place values to be the same, you can now add those decimals. And watch what happens when I add these decimals now. I'm going to do, ready? 3.1 plus 0.338 plus, the last one is 1.1. And check this out. I just got 4.538. That is making sense. Now here's the question. So this equals 4.538 times, what's the power of 10? Well, with addition, you make everything the same size so that you can keep that size. So do I add up these exponents? Definitely not. That would be crazy. That's a multiplication thing to do, not an addition thing to do. So if I just added up this many 10 to the 8ths and this many 10 to the 8ths and this many 10 to the 8ths, if I'm adding them, it's now this many 10 to the 8ths, which, guess what, you guys? This purple number right here is equivalent to this pink one. This one's in standard form, and this one is in scientific notation. But this is still the total population. The key here is, and I'm going to write this down here, so come down with me to the bottom of page 22. Right here, question/notes. I'm going to put this, to add. You cannot add unless the powers of 10 must be the same. Okay? You cannot add in scientific notation unless the powers are the same. And if the powers are not the same, guess what? You got to be super tricky and make them the same. Okay? Let me show you on these two examples here. So the very first thing I look for, if I see, okay, there's my operation. First of all, look up here. Find each sum or difference. Those words mean add and subtract. Write your answer in scientific notation. So your answer needs to be written and kept in scientific notation. We might adjust things and move it out of scientific notation for a minute, but then we're going to put it back. Or our result might end up not in scientific notation, so we have to fix it. So we have to do a lot of move the decimal and balance it with the exponent. You're going to practice this a lot today. You practiced it even with multiplying and dividing, but just remember, it's a balancing act. If one goes up, the other goes down. If one goes down, the other goes up. You got to balance it. So look what I see here. This is addition. Now I check my powers of 10. Are they the same? Yes, they are. If they are the same, I can just go straight to adding those decimals. You can do it by hand. You could do it with a calculator. This one's not so bad because I don't even have to carry anything. This is 9.56. I just added those decimals, but I could only do that because the powers of 10 were the same. That means the place values are already lined up for me. So what do I get for that power of 10? They are the same because I keep it the same the whole time. I want to keep that size. Let's try that again. Look at number 10. It's subtraction, but as we know from 7th grade, subtraction follows all the same addition rules because subtracting is really just adding the opposite. Okay, now I look at the powers of 10. Hey, that's nice, they're the same. So can I subtract these? Absolutely, I can. Now I don't have to keep track of all those zeros. I don't have to put out all those zeros on the end and keep track of my commas. I can just go right to, I'm going to subtract these decimals. 8.96, do I even have to borrow anything? I don't think so. 5.55, is that right? 8.96 minus 3.41, 5.55. times what? 10 to the 7th. Because with addition and subtraction, you get those powers of 10 the same so that you can keep them the same in your answer. So if the powers of 10 are already the same, pretty easy. Add or subtract the decimal, put the power back on, and you're good to go. Come over with me to page 23 now. Page 23 starts to get a little harder. Not right away though. And on this page, anything extra you feel you need to write over here. When you guys upload your pictures, I see that a lot of you only write the things that me or Miss Johnson writes down, and that's okay. But remember, that is for you. So it'd be really exciting for me if one day I saw you wrote something extra over there because you just thought, oh, she said something cool, I'm gonna write it down, even though she didn't tell me to. Anyway, that column is for you. Whatever you need to write there, you write there. Here, I see addition. So I know these powers of 10 need to be the same. They are. Great. Doesn't matter if they're negative exponents, they just need to be the same, and they are. So I'm immediately going to add these decimals, okay? Now, just to remind you, when we say things need to be the same, adding decimals, you're lining up the decimal, you're keeping the place value. That's what this is all about. These powers of 10 are the place value. You could type it in a calculator, you could do it by hand, whatever you need to do. But when I add those, I just get 9.27. And since the powers of 10 were already the same, I leave it the same. If the powers are the same, you just add or subtract the decimals. Okay, what do we do if they're not the same, like number 12? I'm gonna give you this tip right now because people go, well, Miss McGowan, which one do I change? Do I make this one lower to match the 4, or do I make this one higher to match the 6? And the true answer is either one. You can do whatever one you want. I'm gonna give you a tip though right now for what makes your life easier, okay? The tip I'm gonna give you here is, and we'll draw an arrow over here, change the smaller exponent. Make it match the bigger one. And really the only reason for that is because if you change the smaller one, then your answer is more likely to be in scientific notation when you're done. You just usually save yourself a step. So I am going to copy the bigger one because I'm keeping the bigger one, okay? And then I'm gonna show myself here with my blue pen, I'm gonna show myself, I need the exponent to go up 2. It's a balancing act. If I need the exponent to go up 2, then I need the decimal to go left 2, because left is smaller. If one goes up, the other goes down, okay? So if I need the exponent to go up 2, then I need the decimal to go left 2. So I'm going to do that. You ready? And this is going to turn into, I always put a 0 on front. But if I need to go 2, I'm going to go past the 3, and then I also need one more 0. 0.0394. Why did I close that parenthesis? Madness. 10 to the 6th. Why? That's very tricky. That's what I needed to happen. So I can adjust the decimals and the place values to whatever I need. And in this case, I need them to be the same. And why do I need them to be the same? So that I can add them. Okay, so now that I got the powers the same, now I can type in my calculator 4.12 plus 0.0394. You can type that first 0 or not, but you just need to add the decimals now, 4.1594, and then you know the answer is still times 10 to the 6th. If the powers are not the same, you must make them the same. All right. Number 13, it's subtraction, and the powers are not the same. Change the smaller exponent. Ooh, be careful. These are negatives. Negatives. So actually, -7 is the bigger one that I'm going to keep. I'm going to keep the bigger one. And I'm going to change, -9 is actually smaller than -7 because it's farther away from 0. Okay, it's going farther into the negatives. So here, I'm going to make this go up 2, which means again, left 2, okay? And you can see too, if part of the reason you always change the smaller one is because like up here, if I made this go smaller, then I'd have to make this go bigger. And then when I take this big thing and add it to a small thing, then I'm definitely too big. My coefficient is no longer between 1 and 10, and I'm gonna have to fix it, which you totally can. But if you just always keep the bigger and change the smaller, then your answer will more likely be in scientific notation when you're done. So if I make this go left 2, that's 0.045. And now this is 10 to the negative 7, which is exactly what I wanted, because now my powers of 10 are the same. So now I can just go 3.45 minus 0.045. Now I'm just subtracting the decimals. 3.405, and I get to leave it 10 to the negative 7. Why are we making the powers of 10 the same? Because it's all about place value. And when you're adding, you need to line up the place value. So this tricky little thing right here is our way of lining up the place value. You do not have to do it with multiplication and division, but you do have to do it with adding and subtracting. That's true for decimals as well. With decimals, you have to line up the decimal when you're adding and subtracting, but not when you're multiplying. With fractions, you have to get a common denominator, but not when you're multiplying, okay? So, a couple more examples here. Number 14. That is way smaller than that. Negatives are always smaller than positives. So I'm going to leave this one because it's bigger. And how far to get from -2 to +2? This needs to go up 4 place values, which means this needs to go left 4 place values. It's a balancing act. If one goes up, the other goes down. Okay, so 4 place values, 1, 2, 3, 4, and then I copy the rest. That is way too squishy for me. 1, 2, 3, 4. Yeah, I need 3 zeros in front. Times, now this is 10 to the 2, which is exactly why I did it. Now I'm going to rewrite this because that just wasn't working out for me. Now, I don't need a calculator for this. This is 9.0. So this is 9.00064 times 10 squared. I made the powers the same so that I could just add the coefficients. Okay, one last question. It's a word problem and you work on a few of these. It says the Earth is 9.3 times 10 to the 7th miles from the sun. Pluto is 3.67 times 10 to the 9th miles from the sun. How far is it to Pluto from Earth? So this is a difference question. They're asking me the difference between those two. And when you hear difference, you should automatically think subtraction problem. Oh, this is a subtraction problem. So I'm going to set that up. Which one's farther? Oh, Pluto. Okay, so I'm going to go 3.67 times 10 to the 9th minus 9.3 times 10 to the 7th. It is subtraction. That means I need these powers to be the same, and right now they are not. I'm going to keep the larger one, the larger exponent. That's what I'm worried about. I'm not worried about larger decimal. I'm worried about the larger exponent, larger place value. I need this to go up 2, so this will go left 2. So this is going to be minus 0.093 times 10 to the 9th. Now I got the powers the same, so all I have to do, I'm typing in my calculator, 3.67 minus 0.093, and I get 3.577 times 10 to the 9th. And what did I just find? That's how far, so from Earth to Pluto. And that's miles. I should have written that after. That's the measurement, miles. Okay? So the idea here is when you are adding and subtracting in scientific notation, you must line up the place values. And the way that we do that is we make the powers of 10 the same. You're going to practice that a lot. Ask your math teacher questions. You can do this.